Welcome to Video 5C, and this will be the last of our Unit 5 videos. You'll notice there's no 5.6. That's on drawing nets and stuff, and we're going to leave that one off of our summer school curriculum. We're going to move right on to our last three-dimensional figure. So we've had the prism, the cylinder, the pyramid, and the cone, and we've done the surface area and volumes of each of those. And lastly, we're going to do the sphere. And the sphere is different from the other ones. It's actually a lot easier because the sphere doesn't have a base. So the only thing that really affects the volume and the surface area of a sphere, you can kind of think of what it would be. Think of blowing up a balloon or a basketball or something like that that's spherical in shape. The only thing that affects its volume or its surface area is its radius length. So the formula for the sphere, these are the easiest ones. So let's draw a sphere on here. The only thing that affects its volume and its surface area is the radius, which you have to be given. The only way they can get away with not giving you the radius is if they were to give you the diameter, in which case you just cut that in half to get your radius. So very easy formulas. We're going to do volume first. The volume of a sphere actually comes from calculus, so I can't show you where that comes from. It's 4/3 pi r cubed. So some of the formulas I've been trying to show you where they come from because it makes retention easier, but this one takes a lot of really high-level math to prove why that's 4/3 pi r cubed. For the surface area, remember this is filling it up. I call it volume of a sphere. For surface area, again, only affected by the radius. And again, to prove this requires calculus, so I can't show you that. You just have to write them down and use them like maps. 4 pi r squared. You should recognize this part of it, though. That's the area of a circle. So what it's saying is for the, oops, this V should be an S. To cover a basketball that's spherical in shape, it would take 4 circles with the same radius, if you kind of want to think of it that way. And all you need to be given is the radius, so nice, easy section. We're going to leave one of them in terms of pi and one of them in exact here. We're going to do surface area first, so always make sure you grab the correct formula and that you write it down. And then you follow it like a map. My only unknown is r. 4 is a constant. Pi is a constant. R is my variable. They handed it right to me, as they usually do. Sometimes they disguise it by giving you the diameter, and you just need to cut it in half. So I do 4 pi r squared. I'm going to leave my answer in terms of pi. So because multiplication is commutative, which means I can move stuff around, it's perfectly legal for me to multiply these first. Watch, 2 times 3 times 5. I don't have to do 6 times 5 and get 30. I could do 10 times 3 and get 30. And that's what I'm going to do here. I'm going to do 4 times 3 squared. 3 squared is 9. 4 times 9 is 36. So I'm going to take care of the first and third term in the multiplication. And then pi, I'm just going to leave on here. So this would be 36 pi feet. Now if I leave that, that's a length. If I put a cubic on it, that's a volume. If I put squared on, that's for covering things two-dimensionally, which is what we're doing here when we're doing surface area. Next up, I'm going to do this one as a decimal. So you should take a calculator out on this one. And let's, again, write our surface area formula down. It's 4 times pi times the radius squared, which equals 4 times pi times. Let's go over here and grab our radius. They gave me the diameter, so I'm just going to take that 15.6. I'm going to cut it in half. I'm going to realize that that's 7.8. So my radius on this one would be 7.8 inches. I'm going to go plug that in. I'm going to square it. And then I'm going to go to my calculator. And again, if you don't have a pi button on your calculator, then use 3.14. If you're using a graphing calculator, the pi is right above the little caret key. So if you look at where it says clear, and then right below that, there's a little what we call caret key. If you hit the second and then this button, there's a pi up above there, and then you can keep things more exact. So let's do 4 times pi times 7.8 squared. and we get 764.5 to the nearest tenth. And since I'm rounding, I'm going to go approximate on this one. 764.5 square inches, because this is surface area. Volume, I need to change my map. Grab a different map, grab a different formula. Volume is equal to 4/3 pi r cubed. Didn't hand me the radius, they handed me the diameter. So my radius, I'm going to take that 21.6 and I'm going to cut it in half, which gives me 10.8. So I'm going to do 4/3 pi times 10.8 cubed. So I'm going to go to my calculator and I'm going to hit 4 divided by 3 for 4/3. You should make sure you're working this out on your calculator. And then you're going to hit times pi. Remember the pi key is second caret key. Then you're going to do times 10.8. And to raise that to the third power, you have a little caret key right below the clear button, and that's your powering button. So you're going to hit that and do to the third, and you should, if you worked your calculator correctly, you should get, and I'm not going to tell you. The reason is, I want, when I have you come up for me to sign this, I'm going to make sure you knew how to work your calculator for that one. But I'm going to tell you the label because we're now working with volume. We've got 3 dimensions, so we label it centimeters cubed. Next up, we are going to work with section 5.8, which will be nice and easy for you. It's just similar solids, and we've already dealt with similar figures. So our next one should be pretty straightforward. Just trying to get it to turn the page here. Here we go. So for similar solids, I'm going to move that up a little bit. We already talked about how similar figures have all corresponding sides and angles in proportion. Well, 2 solids are similar. So this is going to seem really familiar because we did similar 2-dimensional figures, and similar 3-dimensional figures are basically the same thing. 2 solids are similar if they're corresponding heights, lengths, widths are proportional. Whoops, my A got out of control there. Are in proportion or proportional. Good enough. And remember, for proportion, we set up 2 equal ratios. So what this is saying is all your corresponding heights, lengths, and widths need to be in the same ratio. And there's several ways to check that, but just make sure you grab corresponding parts. So I'm going to go longest side to longest side, 24 to 80. I'm going to check and see if that's equal to, let's go medium side to medium side, 18/60. I'm going to also have to check and make sure that that's equal to shortest length to shortest length, making sure that I'm always putting the left figure on the top of my ratio and the right figure on the bottom of my ratio. And remember the ways we can check this. We can convert them all to decimals. So if you like decimals, go ahead and do that. That's perfectly legal. If you convert all these to decimals, you get a 0.3 right here. And then I do the next one, 18 divided by 60, I get a 0.3. If I didn't, I'd stop right now and say not similar. And then I check the next one, I do 12 divided by 40, and I get 0.3 also. So these are similar. That's my least favorite way. So that's one way, change them to decimals. Another way is to check the cross products. So you could go on all these and see, does this equal this? Go ahead and run a little check. Do 24 times 60, which gives you 1440. Does that equal the other cross product, 18 times 80? And the answer is yes. And then likewise, if you went over here and did it, you'd get the same thing. So checking cross products also yields an answer of S. And the other way to do it is to reduce the fractions. By the way, if you have a graphing calculator and you don't know how to reduce the fractions on there, that's a skill worth noting, especially for standardized tests. You hit 24, you hit divide by 80 to make your calculator reduce that. You hit the math button over on the left-hand side, and you'll notice the number 1 option is frac, so you hit enter, enter. So to reduce that fraction, you hit math, enter, times 2. So you hit enter, enter, and it'll say 3/10. So this is actually 3/10, which you could do by hand. You know, divide each of these by 8. That's totally legal. Divide each of these by 6 gives you 3/10. Dividing each of these by 4 gives you 3/10. So I just showed you 3 ways of showing that those ratios are all in proportion. I changed them to decimals. They were all 0.3. I did cross products. They were all 1440. And then I reduced the fractions. So whatever way you like best. But since this asks me for the scale factor, the third method's the best because then I'm staring at it. The scale factor is 3 to 10, little to big, or 10 to 3, big to little. And we usually like write scale factors as fractions or as ratios. And done. The next one I'll only do one way. So the last one on this video, again, I'm going to check and see are all lengths and heights proportional. Because these are regular, as shown with these markings, I need only check one pair because they're all going to be the same. So I'm checking to see if 18 over 54 is proportional to, unsure, the heights 27 to 81. And it said, if so, find the scale factor. So what I'm going to do is reduce the fractions. 18 goes into 54 3 times. If you're not particularly fond of that arithmetic, again, make your calculator do it. 18 divided by 54, and then hit math, and then hit the enter button twice, and it'll tell you that's 1/3. 27 goes into 81 also 3 times. So yes, these are similar. The scale factor from here to here is 1 to 3. From here to here is 3 to 1. And we're done. Have a good one.